Any quantity which can be measured in units of length is said to have the dimension of length. Also, any quantity which can be measured in units of time is said to have the dimension of time. And any quantity which can be measured in units of mass is said to have a dimension of mass. So in physics, the word dimension is usually used to denote the physical nature of a quantity. The symbols that are used to specify length, mass, and time are L, M, and T. But these three different symbols are usually enclosed in a closed bracket. So they should be enclosed with a closed bracket as L, M, and T. And make sure there's the letter you are using are in uppercase letter. So basically, most physical quantities that has dimension of length, mass, or time has to have dimension formula in this form. So the dimension formula is LMT. Now, how can we find the dimension of physical quantities? Now, we have two different ways to find the dimension of physical quantities. And the first one is by using the formula of the particular quantities, while the second one is by using its SI unit. But basically left to me, I think using the formula is pretty okay because it will avoid you making a mistake. Because if you are not perfect in converting, using the SI unit might be somehow confusing. However, using the SI unit is very, very quick and easier. Like it's very, like just a very shortcut. So let's get into it. So let's focus on velocity first. Velocity. The formula velocity is displacement meter over time, seconds. Velocity is the rate of change of displacement. Now, the dimension formula for meter is L, while the dimension formula for time is T. Therefore, the dimension formula for velocity V is equal to L over T. So we need to write this in this form. We don't need to leave it in ratio, okay? Because basically all of them are written like they are associated together by assuming they are multiplying each other. So don't leave your answer in ratio. Make sure you rewrite it. Maybe you should raise this to the power of exponent, okay? So in order to rewrite this in this form, V will be equals LT raised to power minus 1. Now, the fact that velocity doesn't possess mass, then the dimension of mass will be 0 and the dimension of length will be 1. So let's enclose them in a bracket because they have to be in a bracket. Now, let's focus on the second method using the SI unit of velocity. The SI unit of velocity is equals to meter per seconds. Just as I've said, it's straightforward and easier. Just replace L with M with L and S with T. So therefore, it will becomes LT inverse, then M0, L1. Then you put it in a closed bracket in order to differentiate it. Okay, in order to show that it is a dimension because it has to be put in a closed bracket. Okay, so basically the velocity is dimensionally as L to the power of 1 multiplied by T to the power of minus 1 and M raised to the power of 0. Now let's try one more example. So any other physical quantity let's say we have density. Now feel free to pause the video and try to find out the dimension of density. Okay, density equals mass over volume, because we said density is the ratio of mass to volume. So the dimension of mass is m, while the dimension of volume, we didn't have any specific symbol for dimension of volume, but we know that volume equals length times breadth times height. However, both length, breadth, and height are still distant. They are still referring to distance. Okay, so it means they are all length. So it means we have L length times length times length, which equals L to the power of 3. Now, since L is meter, and we know that the dimension formula for length is L, so we can replace volume with L to the power of 3. So divided by L to the power of 3. Now, let's rewrite it by associating them together. So it means this will be equals to m to the power of 1, L to the power of minus 3, T to the power of 0. So basically, this is the dimension formula for density. Now, what if you wanted to use the SI unit of density? Can anyone tell me the SI unit of density? The SI unit of density is kilogram per meter cube. Okay, we know that kilogram is measured in mass. So mass is measured in kilogram. So we replace kilogram with m divided by length. The dimension formula for length, for meter rather, is L. So we have L cube, which is simply equals to m raised to the power of 1, L to the power of minus 3, and T to the power of 0, and T to the power of 0. So basically, that's how to find the dimension formula of any quantities using either its formula or either its SI unit. So here is an exercise for you guys. If you haven't subscribed to this channel, make sure you do that now. Okay, so feel free to post your answers for review in the comment section, and I will try as much as possible to reply you as early as possible. Don't forget, subscribe now. Okay, so see